Hi, I'm Kumar and welcome to my channel on tech and tutorials. In this session, let us see how to run our unit test from Jenkins by pulling it down from github.com. You can do this with any other cloud hosted repositories like Bitbucket or GitLab, or even within your enterprise environment. If you have any kind of Git repository, hosted Git repository, you can do that using Jenkins and pull it down from that repository and run the test in Jenkins. So for doing that, we need to push our code into repository. We will be using github.com, where we will be pushing our unit test code, and then we will use our Jenkins server running in a Linux machine to pull down the code from GitHub and then execute our unit test in the Jenkins server. So before we push our code into github.com, we have to create a repository for our code to stay in GitHub. So we come to github.com and we can create the new repository by clicking this plus sign in here and then drop down and new repository. We will just name it as demo unit test. You can provide an optional description in here if you want to. And then next, the public or the private option. Public option, as we all know, that everybody can see our code or our files or folders, whatever is there in the public domain. But you can only choose to commit, like you can only commit, or you can have somebody else commit it, but you have to give them authorization. And for the private one, only you can see, and whoever you think needs to see, you can give access and they can only see in case of private repository. I'm going to select public in here, and then we'll go to the next one is about the readme file. I'm not going to create any readme file, and then I'm also not going to add any git ignore file in here. We can push all these files from our local repository, and here I'm just going to create a fresh new repository with everything is empty in my repository. I'll do a create repository, and this gives us our repository, and our repository is created and it provides us all the information what next steps we need to do. And then this is our URL for our repository where we need to push in our code. And then we come to the git bash, and this is our folder, and it's having all our unit test files and folders. And this is our folder where we have all our files. And if I see the git ignore file, I have defined some files in here which I don't want to push into Git. So if you all are aware about Git, then git ignore file is the file where you need to define all the files or folders that you don't want to push into your repository. For example, the log files or the HTML reports and all which you don't want to send, you can define it in this file. So I have defined all my necessary files and folders that I don't want to push into Git. I'll just close this and coming back to our repository. And here we need to initialize our repository first for pushing it into the cloud hosted repository. So we all know the git command. Git init is the command which we need to do to initialize this repository as a Git repository. Git init, and it will create a folder in here, as you see here, .git folder. And here also it says that the folder is created. And now if we do a git status and hit enter, it shows us all the files that needs to be added to our repository, and it will ignore the files that I defined in the .git ignore. So I'll just git add dot so that it adds all the files, and then we check a git status and it shows all this, and it shows all the files that are in the staging area. Now we can go ahead and push this using the commit command, git commit -m, and I'll just put a comment here, first commit, and then all these files will be moved to our local repository. So git commit, and then we do a git status and nothing to commit, working tree clean, and we can do a git log here to see that our commit is fine now. So now our commit ID and all it gave, and our head is pointing to the master branch and author, and then our commit message is defined. So now our file is ready to be pushed to github.com. Then we come back to our GitHub repository. What we need to do before pushing to github.com is we need to set the remote repository. So whatever is described here, you see like git init command, and then they're asking to add the readme file, but I am not adding it right now. We can add it later. And then we did a git commit. Next thing we need to do is git remote add this URL. We need to add it in our local repository. So here I come back and I paste this, and then I hit enter, and then my remote URL origin with the name origin has been added into my configs. So we can see the remotes using the git remote command, which will show us the names, and if you do a -v option with the remote, it will show us the URL also, v for verbose, origin, and the URL it gives us. So what are the remote URLs? It is there, you can see using the git remote -v command. So now all our git related configs or pushing in the local git has been done. Now we are ready to move this code into our remote repository. So git push origin, I will just copy this and then I will paste it here, and this is going to push my code into github.com. So before I hit enter, let me tell you that this origin basically is just a name here, and then this is the whole URL. You can provide the whole URL in here instead of origin and it will be the same. Okay, so I'll go ahead and push this to remote repository, and this is the message which I get, like our local repository has been pushed to this remote and the new branch has been created in this github.com, and then the master branch and the remote is also master, and master set up to track remote master from origin. This is printing because I have given the -u option. -u is set upstream. Basically this option is helpful if whenever you want to pull down anything and you are inside the master branch, if you do a git pull, and it will identify that your local master is mapped to the origin master. So that's why I gave this -u option. And coming back to our github.com, let us refresh this, and we see that all our files are here now. So this is all done. Okay, so before moving on to creating the Jenkins job and all, let me tell you that I am able to push this without providing any username and password, since I have already saved my username and password in my local Windows credential manager. If you are doing this for the first time, you may need to provide something like this. Let me show you that. You can provide the full URL in here, and then you can provide your username and password. So my username and password is KSS7 and then password @ So if you provide like this, it will push in, it will not throw out an 401 authentication error. You are giving the username and password in plain text. So first time you push it like this, and next time onwards you can push in using the same git push origin master without giving the username and password. There are other ways of pushing. Instead of giving the username and password in this format, you can do SSS keys and all those things. But for now, it's okay for us to get started easily and work with it. So I'll come out of this. And now our code is already here in github.com. Let us go ahead and see how to do the Jenkins, how to configure the Jenkins to pull down this code from GitHub and execute our test. So for Jenkins to run our code, we are running our Jenkins in CentOS, in Linux CentOS 7 machine. So in CentOS 7 machine, we have Python version 2.7.5 by default it comes. If I go to one of the CentOS server, if you see the Python version here, it is 2.7.5, and this release is, and the release is CentOS 7.4. And in most of the other CentOS 6 or 7 or 8, it comes by default with 2.7.5, and it has some of the scripts and libraries that uses this Python. So it is coming with 2.7.5. So we need a Python version 3.6 or above in this machine. For that, we can use the software collections provided by Red Hat. And then this works with CentOS 7 because CentOS is based on Red Hat Linux. So I'm going to use this software collections for installing the Python 3.x in our Linux CentOS 7 machine. SCL actually says software collections libraries will allow us to install new versions of Python and along with the default 2.7.5 so that all our other tools and yum and all of within CentOS 7 works properly. We can also directly install Python 3 for all the users in system, but this works like a virtual environment and you can enable and disable it within this Linux machine. I am going to show you how to install this SCL. I have already installed this in my Jenkins server, so I'm going to try it out in another CentOS 7 machine. So for installing this SCL library, you just need to copy this yum install CentOS release SCL and go back to our Linux machine and paste it here. By the way, you need to be logged in as root, or you need to ask your system administrator if you don't have root access. So I'm going to install this and say Y so that it doesn't ask for any confirmation. and hit enter. And this is done with the installation of the CentOS 7 SCL software collections, CentOS 7. And we need to install the RH Python 3.6. So yum install Python RH Python 3.6. This will install Python 3.6 in this SCL collection, software collections, within the software collections. And then I paste it here with a -y and hit enter. Okay, so this is done with the installation, and for enabling the SCL, the command is also here. You can use this, start using the software collection using this SCL enable RH Python 3.6 bash, and you just paste in here, and then if you see the Python -v, you can see that now we are in Python 3.6.9, and if you type which Python, you can see that it's using the RH Python 3.6, and then this is the whole path for the Python. Now you are in Python 3.6. If ever you come out, if you want to work with this machine and you want to work between different versions of Python, you can again come back to 2.7.5 using exit, and then you do a Python -v. You can see now it is 2.7.5, and if you type which Python, this is the user system default Python which comes with the installation, user bin Python. So we are all done with setting up the SCL software collections for Python 3.6, and then next we can go to Jenkins. So coming back to Jenkins, let me log into my Jenkins machine. Okay, so now I am in my Jenkins server, and then we can go to a new item and we can name this as demo unit test Python. And we'll select a freestyle project, and then we click OK, which brings us to a job configuration page. You can provide an optional description and source code. So this is the main thing where we are going to fetch our code from. We select Git in here and we copy the repository from here. So this is our GitHub, and this is all our unit test files, and we go to clone and download and copy this whole URL. We come back here and then we paste it. Okay, so by the way, my repository is public repository, that's why it's not throwing up any error in here. If this was a private repository and it requires an authentication and all, you can add the authentication from here, add Jenkins, and you can provide the username and password and select that. In this drop down it will be able to access that your repository from GitHub. So that's about the Git, and next is the builds tab. So once I come in the builds tab, we are just going to execute these scripts or this Python test using the shell. Shell means the Linux shell. I'll just make this little bigger. So whatever I'm going to put in this commands, whatever commands I'm going to put, you can put it in a bash script or some shell script and put it within your repository, and you can download with the code and you can run it. But I'm just going to show it here so that it's easier for everybody to understand and follow. So I'm just going to copy the first part and paste it here. So I'm going to explain what each one of these lines are going to do in here. So we need to define the bash shell on which it will be executing, bin bash. This is for any kind of bash scripts and all. And then we are going to source the RH Python 3.6. If you remember, we did SCL enable RH Python 3.6 bash. So this is what we are doing here. From the script we need to use this command, source SCL_source enable RH-Python 3.6. This is going to enable the Python 3.6 in our Jenkins machine. Next line, we are creating a virtual environment, and this is just a variable which we are defining and just naming it as virtual environment. Then we are going to creating a virtual environment using this command Python, which is, once we enable this RH Python 3.6, this Python would have been 3.6, and our code is also in 3.6. That's why we need to use 3.6 Python, and then -m venb. This is a simple command to create a virtual environment in Python 3.x, and then -m venb, and then the virtual environment name. And then we are going to activate our virtual environment, whatever virtual environment which we created here, we are going to bin activate. So this is the same like we have seen in Windows system also. There is an activate script within this bin folder, scripts bin /activate, same thing in Windows, and this is also same thing in Linux as well. And then we are going to install the pip install -r/requirements. So in Jenkins, when the code is downloaded and pull down, there will be a folder created, and within that folder we are working. So this script is getting executed within that folder. So when we do a pip install -r/requirements, if you see in our code here, there is a requirements here. So these requirements are all the libraries and packages that our script or our Python project needs. You can generate this using pip freeze and then the greater than symbol and then this requirements.text. This pip install -r/requirement is getting executed, and all the packages and all are getting installed within my virtual environment that I'm creating in here. Next we are going inside the job name. As I said, when you run this job in Jenkins, it's going to create a folder in the name of my job name is demo unit test Python, and it's going to create a folder in there. So, and the path is in all Jenkins servers, the path is where lib Jenkins workspace and then the folder name. Folder name is your demo unit test Python. Here I am referring using a job name. So this variable is coming from Jenkins, and using this variable you can get the job name. So in my case it will be demo unit test Python. So once I am inside this folder, I can run our test. So this is the code which runs the test. I'm just doing an echo run test. You will see this echo in the std out when we run this job, and then our test Pytest, and then our folder is my test. If you come here, this is our folder my test, and inside this all our separate test modules or test files are there. This is our test folder. So in Pytest, if you define the folder name, it will run all the tests inside that folder. And then we are generating the JUnit report using this command test-JUnit XML and then /XML report and output.xml. And this output.xml, we are going to use it in our next step, PostBuild Action. And then finally, the last two lines is deactivate. Deactivating is our virtual environment we are deactivating. Deactivate command is for deactivating our virtual environment, and exit command is exiting out of the SCL source rhpython 3.6. Okay, so that's about this whole script. And next we go to the post build action and publish JUnit test report. Here we can define this output.xml. We can just copy this here. Basically this executes from within the workspace folder. It's this path where leave Jenkins workspace and then the job name, which in our case is demo unit test Python. We'll see that in a minute in our Jenkins when we run this job, and this file is within that. So whenever post build action is run, it is running from within that folder. So I can just directly refer XML report output.xml, and this will help us generate our test reports. Okay, basically that completes all the necessary configuration for our Jenkins to pull down code from GitHub and run our test. So next I will just save this, and this will bring us to our jobs homepage, and then we can do a trial run here, build now, and our job started to run in here. So let us go to the console output and see what it is actually doing. So if you see here, it's the Git, it's fetching all the information from github.com, cloning this repository, and then it got all the files and folders, and you see all this activate virtual environment and all whatever echo we are doing, it's getting printed in here. And then next thing is doing this, installing these libraries, pip install -r requirements.txt, whatever we define, it's getting all these libraries in our virtual environment. And then next it is running our test. So it is complaining about test underscore parameterized, about module not found, no module name parameterized. We are using the module parameterize and it is not finding this module. We will fix that in a minute, but you can see that all our test has ran successfully in here, except these failures. Of course, we will fix it in a minute. And that's about all. And we come back to our project, and let me also tell you one thing in here related to Git here. So if you see here, the branch which is specified in here by default is /master. And if you come to github.com, you see that we have only one branch here, master branch. If I would have had different branches and all, I can actually define the other branches / some feature 1 or branch 1, branch 2, like that. So by default, Jenkins will populate this with the master branch. That's what you are seeing. Okay. So I can go back to our project, and then we need to fix that issue parameterized. So for that, let us come to our project and let us see our requirements.txt. If you see here, there is no parameterized module which we are putting in. That means what we can do is we can go to our command prompt and we can enable our virtual environment. So our virtual environment is venv scripts activate. Here this is a path for Windows for activating this virtual environment. I'll just enable this, and what I can do is pip freeze requirements.txt. Pip freeze requirements.txt will take all the libraries for this project and put it in this requirements.txt file. I had already one requirements.txt file which is missing the parameterized library, so I can just hit enter here and this would have updated our requirements.txt. And once I come to git bash, I'll clear this screen, and if we do a git status, we can see that modified requirements.txt, and we can do a git add dot again, and we do a git status, and we see that our file is moved to the staging area modified requirements.txt, and we can do git commit -m updated requirements.txt file and save it. And then we do a git status, working area is clean, and then we do a git log, and we see that now we have two commits here, and you see the git status command here, your branch is ahead of origin master by one commit, which is correct what we did. And we can do a git push now origin master and hit enter, and now our second commit has been pushed to github.com. Now if we come here, now it's only having one commit, and let me refresh this and see that now it is having two commits. So our changes have been pushed. Our requirements.txt has been updated, and it's showing updated requirements.txt file. This was the last commit, second commit. And now we come back to our Jenkins project and we do a build now again, and it's running this one, and looks like it got passed. So you see here it is not again downloading the libraries and all. Requirement already satisfied. The folder is already created the first time you ran, and it is not getting updated again. But if you see the parameterize, collecting parameterized version 0.7.1, and it got pulled down. It got pulled down because it was not there from the first time. So whatever updates you do, it got pulled down. And then other things which we want to see is we want to see all our tests have ran here and the finished success. So that is all fine, and you can see the test runs in here. After the second execution, we can do another test run and we can do a refresh and see our test runs getting updated, and the latest test results. From here you can go ahead and see if there are any issues or failures. So that's about pushing our code to github.com, and then from Jenkins we are pulling down and executing our test. That completes our full cycle of CI, or continuous testing, continuous integration and testing of our source code. That's all in this session. Thank you so much.